I want to introduce Patrick O'Neill from the Center for the Advancement of Science and Space and just say a heartfelt thank you to Patrick and the entire family at CASIS for making SSEP possible.
Well, good morning, everybody. First of all, thank you very much, Jeff, for the kind words. And you know, it honestly is it's a pleasure on our end to be able to know that we have the opportunity to help, use the space station as a mechanism to excite the next generation of scientists and engineers. So, with that, though, I wanted to kind of give you guys a brief overview of what's actually happening on the space station from a research perspective, both from a CASIS standpoint as well as from a NASA standpoint. So I guess, real quick show of hands, who knew prior to any of this that the space station was actually a national laboratory? Anybody? Well, I guess you kind of are forced into it. Yeah, there you go. All right, let's see if we can get this thing started. Boom. Okay, so real quick background on CASIS and the International Space Station National Laboratory. So in 2005, Congress in their infinite wisdom said, you know what, this space station is really cool. You can do an awful lot of research on it, but the problem is that there's only so much that NASA can do, and their role is about exploration, living, working in space, better understanding the human condition so you can go to Mars, go to an asteroid, go to an outside galaxy, something of that nature. But there's a lot of other things we could be doing that might translate to benefiting life on Earth. There could be commercial companies that want to take advantage of the space station. There could be academic researchers. There could be students who want to take advantage of the microgravity environment. So why don't we turn this into a national laboratory and open it up to the masses? So that's what they ended up doing in 2005, and in 2011, NASA selected CASIS to manage the national laboratory. So we've been doing that now for just about 5 years. So ultimately, our goal is to use the space station to benefit life on Earth. You can see the 5 main areas, I guess, that we kind of specialize in. And it ranges from everything from life science, physical science, material science, technology development, remote sensing, Earth observation, and yes, education. Okay, so it's been a busy year in space. A lot of stuff's been going on. I saw some of the students talking earlier today about the Martian and some of that being kind of the inspiration for some of their payloads. And, there is something to be said about Hollywood. When Hollywood starts doing movies about space, it reinvigorates the public that much more so, and it gets people a little bit excited about what's happening on the space station. Me, as somebody who works with the media on a daily basis, it's when movies like that come out, my phone starts blowing up because they want to figure out what the space station is doing that can enable that type of opportunity one day down the road. Obviously, SpaceX, what they're doing right now is absolutely incredible. The same thing for Blue Origin. Being able to send rockets to microgravity, a low Earth orbit, and then being able to send those boosters come back down and land and be able to reuse them over and over again, that's going to prove invaluable to us, down the road. Right now, it's cool, but think about it from the standpoint of 10 to 20 years. That's going to be just something that continuously happens over and over again, and it's going to make the opportunity to access station, to access microgravity that much easier, that much faster for everyone else down the road. Scott Kelly spent a year in space, or 340 days, depending upon, but I'm not going to go out there and begrudge the man the extra 20-plus days that he missed out on for the full year. What he was able to do on the space station is also going to be invaluable for NASA as we continue to explore and go beyond low Earth orbit. So from a national lab standpoint and a NASA standpoint, what types of research has been happening? And honestly, the question is, or the answer is lots. Again, everything from life sciences all the way down to using the station as an Earth observation remote sensing platform or a satellite. So let's focus on some of the things that have happened over the last year. So you got some rodents. We like to send little moustronauts to the space station. Our friends at NASA don't like it when I call them that, but that's okay. So one of the great things about astronauts, and obviously we saw Dr. Thomas here earlier, but the astronauts themselves get to basically be guinea pigs when they're on the space station. And we have learned so much about how their body morphs over time in a microgravity environment. In particular, one of the things that they have always tried to combat is what's happening to your body from a muscle wasting and a bone density loss standpoint. I believe that they say that if an astronaut on the space station, if they don't do any active movements, if they don't constantly work out, they can lose upwards of 1.5% to 2% of bone density per month. And that's the equivalent of an 85-year-old osteoporotic woman. So what we like to try to do is we send these little rodents to the microgravity environment on the space station, and we can use them as a way to better understand muscle wasting, bone density loss. The average rodent lives only a couple of years. So if you're able to stick it in a microgravity environment, an adult rodent in a microgravity environment for 30 to 60 days, you're going to be able to learn a heck of a lot about their physiology, and you can also use them as a way to test therapies so that ultimately we can benefit life on Earth, create more potent and better therapeutics for the aging population here on the ground. Protein crystal growth, crystallography. In a microgravity environment, you're able to grow better, more defined crystals, and that can also lead the way to better drug discovery, drug development. So we see an awful lot of pharmaceutical companies, life scientists, who want to take advantage of the microgravity environment so that they can develop bigger, stronger crystals again. Veggie. So Scott Kelly, he's in that picture in the top right. So if we do go to Mars, we're not going to be able to send a whole bunch of food with us. So almost like what you saw in The Martian, where he had to grow his own plants, grow his own food, you're going to have to do the same thing when you're going to send astronauts to a place like Mars, because I believe it's a 9-month trip there. Then they're going to be on Mars, and then they got to come back. So you got to find ways to develop food, and so that way they're going to be properly nourished. And that's exactly what the veggie experiment was from NASA's perspective. And a few months ago, they actually had the astronauts eating the first veggie experiments that were conducted on the space station. So this is all leading to hopefully being able to send astronauts to and from Mars in the late 2020s to going into 2030s. Then morphing down into what's happening with the Kelly brothers. So it's not just the fact that Scott Kelly spent 340 days, almost a year in a microgravity environment to better understand what's happening to his body, but the really unique thing about his situation is that he's got a twin brother, Mark Kelly, and Mark Kelly is also a former astronaut. But what they were able to do is they were able to conduct a twin study, and they could use Mark as the test bed here on the ground while they used Scott as the guinea pig in a microgravity environment to see how the body adapts, how it morphs over time. Because you have both of these individuals who have such similar genetics, you might be able to look at what's happening between the two of them and see, again, what happens to your body by being on the space station for such a prolonged period of time. Typically, the astronauts are up there for about 6 months. So again, you doubled it this past time with Scott Kelly. And so they're still evaluating a lot of the research that happened from a Scott Kelly perspective. But it's actually funny. We're going to be in 2 weeks, we're going to be in San Diego for the International Space Station Research and Development Conference. And both Mark and Scott are going to be there. Scott's flight surgeon, as well as some of the lead investigators who were involved in the twin study, are going to be there talking about some of the preliminary findings associated with that year in space mission. On the bottom right corner, genes in space, better understanding the immune system. And that's actually a student payload that again, was trying to better understand what happens in a microgravity environment so that we can have sustained, time in a microgravity environment. Material and physical sciences. So on the left, we have a really unique payload that came from a commercial company called Millikan. You've probably never heard of them, but the running joke for them is that they say that on average there's about 50 things that you touch every single day that is something that they either created or were in the process of creating and then sold off to somebody else so that they could use. But one of the things that they sent to the space station that's a really cool payload is trying to send flame retardant textiles to the microgravity environment so that they could possibly enhance the fabrics associated with firefighters or first responders. So it's using the space station as a mechanism to not only improve life on Earth, but to make things safer for the individuals who are in harm's way. So that's a pretty cool idea. Do we have any golfers here? I will be hitting the links later on this afternoon, yeehaw. And when I do so, I will be using the King LTD driver, which is also being used by Ricky Fowler. So 2 years ago, Cobra Golf sent research to the space station looking at materials and alloys so that they could create, quote unquote, the world's most innovative golf club. But what they did end up finding is they're still evaluating their research, but through the partnership with CASIS and some of the things that have happened in the past with NASA and other rocket providers, they were able to find a solution for some issues that they're having associated with torque and torque ratio in their golf clubs. And so what they ended up doing is they took some fabrics that are used for rocket launches, and they said, you know what, being able to hit a driver is almost the equivalent of what happens to metals and fabrics when they're launching something into a microgravity environment. So let's take some of those spiral lock kind of fabrics and put them into our golf club, and maybe they'll be able to make a more efficient product. So that's the end product right now. It's on the market, so by all means go out there and give it a whack. On the right, we have, that's actually Luke Skywalker's arm from Star Wars. I hope that George Lucas doesn't sue me. But it's looking at the space station as a way to create synthetic muscles, robotics. I was chatting with somebody earlier. I think that there were some young ladies that were looking at Robonaut and using robotics as a way to make things more efficient on the space station. So if you can develop synthetic muscles or help things from a robotic standpoint, that might make it a little bit easier for us to go on the outside of the space station and have a robot fix things that are wrong with the space station or implant things into the space station so that it makes it that much more of a first-class laboratory setting. Another thing that we're constantly doing on the space station is trying to find ways, so I mentioned earlier, to try to make it a more world-class or first-class research platform. So there's been a lot of things that are happening on the station, and just recently there was the beam let's see, I believe that we can't call it the extension, we have to call it the expansion of the beam. And so I'm not sure if anyone's familiar with that, but Bigelow Aerospace, they sent a hardware facility, and that's the beam expanding right now. And there's two things associated with it. One, they wanted to be able to use this as a test model so that they could expand something on the space station and then eventually put some possible research payloads on the inside of it, and you have a little bit more room to play with. But the other side of the coin, too, is one day down the road, we might have the opportunity to do space tourism or something of that nature. And so this is kind of that test bed to see how their fabrics, how their materials are going to work in a microgravity environment because, hey, 20 years down the road, if you want to go on a vacation to outer space, that might be your conduit to making that happen, and you might end up staying in something very similar to what Beam is sending up right now. It's pretty unique. We now have a 3D printer on the space station. We actually had a 3D printer about 2 years ago, but that was a test model. And so now we have a more quote-unquote commercial that is open to everybody. It's not just something that NASA can use to build parts, but it's also something that we can use as a way to iterate. And what I mean by that is there's a lot of research that happens on the space station where instead of sending your payload all the way back down and evaluating it and then a couple years later trying to send something else back up, you might now have the opportunity to evaluate research in a real-time environment and then say, you know what, it'd be really cool if I could toggle the variables in this manner and all I need is this tool to do it. Now you have a 3D printer that can possibly create that tool, create that hardware apparatus that you're going to need, and you can do your research and continue to do your research and be able to get the results that you want in an expedited manner. So what else is going up this upcoming year? So talked a little bit about things like rodent research. We have stem cells that are going to the space station trying to better understand the cardiovascular system. So it's going to be a payload, I believe, from Stanford that's going up. We've already had a variety of protein crystallography experiments that have gone up from a pharmaceutical company called Eli Lilly and Company. We're continuing to send more and more facilities to the space station. I believe that the vast majority of you are all using Nanoracks nanolabs. So right now there's a variety of facilities that are available to the public that you can use, and we're going to be sending even more facilities that provide additional rack space, additional opportunity for experimentation. We can now use the outside of the space station to put payloads and see how they react in the extreme environment of space. You have everything from high radiation to extreme temperature variation. You can be 300 degrees 1 second, and a couple of minutes later you're going to be minus 300 degrees in that environment. So how do things work in a microgravity environment when you put them to that type of an environment? Also, a lot of STEM payloads. We're going to be using the space station for maritime awareness. So they're going to be using the station as a way to be able to plot and figure out where boats are in ocean environments, distressed areas, and it basically, again, it's being able to use that as almost like a GPS system so that we can make sure that everyone is safe in treacherous waters. And the one that I think, from me as a marketing and PR person, that I'm getting the kick out of the most is all the students here are probably way too young to remember, not even born yet, to remember the Chernobyl nuclear power plant issue or accident that we had a little over 30 years ago. But we're going to be sending fungal strains from the Chernobyl power plant to the International Space Station. And the thought process behind that is that if fungal strains can survive that type of nuclear explosion and 30 years later they're still functioning, what's going to happen when you send them to a microgravity environment? What keys might they be able to unlock from a biomedical standpoint and an agricultural standpoint? If they're able to withstand those rigors, it might be a way for us to go out there and kind of unlock things and use them to, again, benefit life on Earth. So that's kind of what's going on. previously over the last year or so, and then what's going to be going up on SpaceX 9 and 10 and Orbital 5 and Orbital 7 the remainder of this year. So happy to answer any questions that you guys might have associated with what's happening on the space station. Thank you very much, and congratulations to all of you for being here. This is terrific. So.
Anybody have any questions for Patrick?
What do I dig most about my job? I guess the chance that I tell this to the science people all the time, that you can send great research to the space station, but unless you have me to sit there and communicate it, ain't nobody going to know about it. So I think the fact that I'm the gatekeeper for all this stuff is pretty cool. And on top of that, it's interesting because I was making the joke earlier, there's a good chance that all the students in here are probably going to forget more science than I'm going to actually know. I took one science class in college at Big Bad San Diego State, and now I have the opportunity to come here and talk about it all the time and make you think that I know what I'm talking about.
So when you were doing that in San Diego State, did you know this is what you were going to end up doing? How did you get into the space business?
Well, if you were to tell me that 10 years ago when I was graduating college that I would now be working for the International Space Station, I would tell you that you probably have to go and take a drug test. But no, it's really kind of funny how things ultimately work themselves out. I literally just ran into the right people at the right time. And what I would say to all the students here, as you go forth and go into university environments and beyond that in a professional realm, network, connect, talk to people, ask questions, get involved with a variety of organizations, because you never know who you're going to run into. And at some point in time, you might end up running into somebody who works for the International Space Station, and they might have a job for you. You never know.
You know, Patrick, I think another related topic is that it takes a team, a multidisciplinary team, to do anything these days, including the space program. Mm-hmm. And often we think about the space program, well, the astronauts come to mind, scientists and engineers. But behind the scenes, what are the other flavors of folks that make a space program work? Because I think that there are a lot of students that don't understand that there are passions and gifts and dreams that they have that aren't necessarily science and engineering, but they still can be part of this frontier.
Absolutely, that's great. So from our standpoint, there's everything from scientists to engineers to operational people to contract people to me, like the marketing communication folks. There's so many people that are involved, both from a CASIS standpoint, a NASA standpoint, and it really takes everybody working together and streamlining communication messages so that everyone understands the mission, understands what we're trying to do. And, again, if you look at NASA, I mean, there's just been, over 500 astronauts that have gone into a microgravity environment, but there's hundreds of thousands of people along the way that have helped to make it possible for these individuals to go into a microgravity environment and ultimately come back. So, I think to your point, there are so many things that are possible to be done in the aerospace community. And then secondary to that too, there's not just NASA now. There's so many emerging companies. There's the SpaceX's, there's the Blue Origins. There's so many things that are happening from an aerospace perspective that are just burgeoning right now. And it really opens up the door to a lot of people that are interested. I mean, if you have a passion for space, if you have a passion for rockets, engineering, then this is the time, I think, to really be able to take advantage of that, because there's going to be so many opportunities available over the next 10 to 20 years.
Wonderful. Well, let's thank Patrick one more time.
Thank you very much.